For question 10, the polynomial px are given cubic polynomial x cubed minus 2x squared plus ax plus b. So it said it have a factor. So means that this is a factor theorem. Our polynomial equals to 0, where we substitute x, the value equals to 2. And leave a remainder of a cubed means remainder theorem equals to a cubed when it divided by x minus a. So our x value here will be put in x equals to a. So we have to use these two information to find out what is our values of a and b. Firstly, we write our factor correctly, where when we have x equals to 2, substitute into the polynomial, and it is a factor, so it will give us equation 0. Then we start to substitute our 2 into the polynomial. It will equal to 8 minus 8 plus 2a plus b equals to 0. And then second concept here will be our remainder theorem. When our x is equals to a, so our PA remainder is equals to a cubed. So therefore we substitute a here, it will equals to a cubed minus 2a squared, and then plus a squared plus b equals to a cubed. So notice here, we can simplify our a cubed and then we get the equation negative 2a squared. Negative 2a squared plus a squared also we can simplify. We can get a negative a squared plus b equals to 0. So here we can simplify. So this will be our second information. So for the first information, I have to simplify it in order to start our simultaneous equation. So this is equation 1. This is equation 2. So I can see here I have a similar b. So we can do eliminated method, where I will take equation 1 minus equation 2. So 2a minus negative become positive a squared equals to 0. We get a quadratic here. So when we get a quadratic equation, we factorize and we find out the value, where a is 0, a is negative 2. So we have two answers here. So when we have two answers here, when I substitute back into equation 1, I also will have two answers of b. So b will be equal to 0. When I substitute a 0, b will equal to 0. When I substitute a equals to negative 2, b will equal to 4. So conclusion, I have two set answer, a 0, b 0, a negative 2, b is 4. So this is our first part, how to find out our a and b. So therefore, this is the basic that we need to know for our factor theorem. And this is the basic for our remainder theorem. And then substitute both value, concept of substitute both value, and solve the simultaneous equation to get two answers of A. Finally, also can get two answers of B. Then we proceed to question B. Factorize the px completely by using the AB from the part A. So I have two sets of answers. So I have two polynomials to do the factorization. Hence, find the roots of this polynomial, where the a and b are not equal to 0. So for the first part of the answer, if my a equals to 0, b equals to 0, the polynomial that I get here, it will be x squared, x cubed plus 2x squared. So another answer, if our AB is not equal to 0, if my A is negative 2, B is equals to 4, my polynomial here is equals to negative 2x squared, negative 2x plus 4. So I have to factorize completely by using this AB obtained from the A. So this is my first task. Factorize these two polynomials completely. So for this, it will be easier because once we take out factorize out our x squared, it will be x minus 2. So this we factorize completely. But for this polynomial, how we going to factorize it completely? For cubic polynomial, we need to divide its factor. So we can find this polynomial, it has a factor of x minus 2. So I have to divide by this x minus 2 factors in order to find others factors. So that's why we will undergo our long division and divide by its factor x minus 2. So how to do long division? We will find the multiplier here. So how to find it? We will divide by x cubed divide x. So your multiplier here is 2. Then we expand. Okay, so we multiply back. Then you'll notice that your x cubed will be cancelled. So when we minus, it is 0. When I minus here also 0. So this part minus 0, it still have a reminder negative 2x plus 4. So still can do our division. We can proceed our division because this is linear. This is also linear. They are same. They still can divide. So we can find a multiplier of negative 2 so that I can get negative 2x plus 4. So from here, the polynomial is equal to x minus 2. The quotient is x squared minus 2. Then we look at the factors here. The other factor here, quadratic. This factor cannot be factorized anymore. So this will be our complete factorization for the part B, first task. Then second task, they said hence. For the second task, hence, I have to find out the roots. For the case the AB is not equal to 0, means I need to proceed for this polynomial and find out the roots. So for the x equals to 0, we will make the factors equals to 0 in order to find out the roots. So x will equal to 2. Here, x squared will equal to 2. So x will equal to positive negative square root 2. So therefore, the roots here is x is equals to 2, x equals to 2, x equals to negative 2. So therefore, for the first part, for the first answer, factorize it completely. And for this polynomial, factorize it completely. And then we let it into 0. We solve for our x. That will be our roots. So this is in factor form. When x equals to something, this is what we call roots.